Okay, so hi everyone. We are going to look at auto scaling today along with launch configuration. So for that, first we will go ahead and look at the theory, and then we will look at an architecture diagram, and then we will implement the architecture diagram. Okay. So let us first understand as to what launch configuration is. So launch configuration is nothing but, so if you have seen my previous videos, you will know as to how to launch an EC2 instance, right? So all the steps that you do to launch an EC2 instance, those are the similar steps that you will have to do to create a launch configuration. The only reason why you will need a launch configuration is because if suppose the auto scaling group itself decides to add any new instances, or if the auto scaling group itself decides to terminate any instance, and when it launches a new instance, it should know what AMI or what configuration it needs to have, right? So you shouldn't be the one who's going to do those configurations manually. So you should set it in stone once, and then the auto scaling group is going to go ahead and take that configuration, and it's going to use that configuration to launch any new EC2 instances which are similar to those that are currently running within the auto scaling group. So for that, we need to specify a launch configuration to our auto scaling group. So when we look at the demo for this, you will get to know that the launch configuration is nothing but the exact same steps that we will do when it comes to creating an EC2 instance. So all the necessary configurations in such as like the AMI ID, the instance type, then we will go ahead and specify the EBS volume for that instance, and then we will also have to mention one or more security groups, and then all that we have to do at the end is create tags, and then go ahead and choose our key pair, and then automatically it is going to redirect to the auto scaling configuration. So launch configuration is pretty simple. It's the same steps that you use to go ahead and create an EC2 instance, but with maybe a little bit of lesser configuration, because that launch configuration is the one that is going to be used by the auto scaling group to go ahead and launch any new EC2 instances within the auto scaling group, right? So, and then we can specify only one launch configuration at a time for an auto scaling group. The only reason is because the auto scaling group should be aware that I'm going to launch only this particular configuration of EC2 instances. You cannot specify more than one. That is not possible. But what you can do is you can go ahead and create the launch configuration and associate it with an auto scaling group. You can't modify the launch configuration after you have created it. So there is nothing called as updating a launch configuration. You can't update a launch configurations once you have created it already. The one thing that you can do is you can create a new launch configuration, which is a copy of your previous one, but probably with the different configurations, and then update the auto scaling group with the latest launch configuration. So that is possible. So if you have one launch configuration attached to an auto scaling group, what you can do is you can go ahead and create another launch configuration, which is a replica of the first one that you created, but just that you have different configurations this time, and then you can associate the second launch configuration to your auto scaling group. So what the auto scaling group will do at that point of time is it will go ahead and try to launch new EC2 instances with your latest launch configuration, and then it will go ahead and remove the existing EC2 instances with the older launch configuration. Even if you terminate the older instances manually by yourself by going to instance actions and terminate, the auto scaling group is going to launch new instances to maintain the desired capacity, but this time it is going to launch the instances with the latest launch configuration that you have specified rather than the oldest one, right? So in the way that you want to upload or you want to update your auto scaling group to utilize the latest configuration, all you have to do is go ahead and create a new launch configuration and update the auto scaling group. So you can't modify the existing one once you have created it, right? So the next thing that we are going to see is a little more details regarding the configuration. So the auto scaling group is nothing but a collection of EC2 instances that are treated as a logical grouping. So what we can do is the auto scaling group needs to be specified with a desired capacity, a minimum capacity, and a maximum capacity, right? So the desired capacity is the one that it's always going to try and maintain. So the auto scaling group's behavior is to always maintain the desired capacity, but then we can specify our own uh, scaling policies, and in those scaling policies we can mention that if the CPU utilization across my entire fleet is less than 80%, is less than 20%, then I can go ahead and remove an instance, or I can terminate an instance. But if the CPU utilization is greater than 80%, I can go ahead and launch 2 more instances to my auto scaling group. So then which launch configuration it is going to use? The same launch configuration that you associated with the auto scaling group. But at all points of time, the auto scaling group will maintain the desired capacity. So if you mention 4 EC2 instances to be your desired capacity, it is always going to try to maintain that 4 EC2 instance. And again, so where does this auto scaling group find out whether an instance is healthy or not? So what we are going to do today is we are going to have an application load balancer sitting on top of the auto scaling group across multiple availability zones. So now this application load balancer is going to monitor our instances health through health checks. And then our auto scaling group's health checks retrieval will be from the load balancer. So the auto scaling group is going to ask the load balancer, let's imagine it like that. The auto scaling group is going to ask the load balancer, can you tell me the number of healthy instances? And if the auto scaling group returns back with 2 healthy instances and your desired capacity in your auto scaling group is 2, then the auto scaling group is not going to do anything. But if suppose the load balancer is going to return only 1 as your healthy instance, and the auto scaling group is going to get that metric from the load balancer, and then you have specified as your desired to be 2, which is greater than 1, then the auto scaling group will try all in its power to launch 1 more instance to maintain that desired capacity. Right? And if suppose an instance becomes unhealthy within the auto scaling group, it automatically terminates that instance and then launches another instance to replace it. So this is the property of an auto scaling group. So when we studied about load balancers before, one thing that we saw was the load balancer does not send traffic to an instance that is unhealthy, right? But it does not replace the unhealthy instance with a healthy instance. Now the auto scaling group does that. So that's why we will do auto scaling group in combination with load balancer and choose our health checks to be from the load balancer rather than the instances directly. So the auto scaling group has a property where the health checks can be directly on the EC2 instance, or the health check can be retrieved from the load balancer. So we are going to spawn an application load balancer and go for the health check from the application load balancer, right? So the next configuration that we are going to study about is regarding the scaling policies. So when it comes to the scaling policies, we can mention a step or dynamically scaling policy where we can mention that this is going to be my minimum and maximum capacity of my auto scaling group, and based on a specific metric, probably from CloudWatch, which is called as CPU utilization, or probably the network in metric of an EC2 instance, we can go ahead and scale the EC2 instance. So while scaling the EC2 instance, you can specify that, like I mentioned before, if the CPU utilization is less than 20% or 30%, go ahead and remove an EC2 instance. If the CPU utilization is greater than 80%, go ahead and launch 3 more instances. But then that instances, those are launched, right? It is always going to be up to your maximum capacity that you have mentioned. It's not going to go more than your maximum capacity. So if you have mentioned 20 to be your maximum capacity of EC2 instance, and it keeps launching instances, it will never go above 20. It will only stick to 20, right? You can also scale based on a schedule. So scheduled based scaling is also possible, wherein we can mention at this point of time, on this particular date of this particular year, I would like to modify my min, max, and desired. So if suppose there is an Black Friday sale by Amazon or by Flipkart, then we can imagine that what they can possibly do is on 22nd of this particular month, on this at this year, on this particular time at around midnight, 12 o'clock, I would like my desired capacity to be 6, my minimum capacity to be 4, and my maximum capacity to be 12. So that is very much possible. So scaling based on schedule is also possible. And if suppose in order to reduce cost within your auto scaling group, you would like to launch on demand instances and spot instances, or a combination of both, you can't use a launch configuration. You will have to use only a launch template. So we will look at launch template at a later lecture, but for right now, just remember that if you want to use a combination of on demand and spot instances in your auto scaling group, you will have to go with launch template. Okay. So now if suppose when the instances are launched and you specify multiple availability zones, the desired capacity, if suppose it's given as 2, will by default be distributed across both of the availability zones. And even if a scaling action occurs in order where the auto scaling group is going to launch any new EC2 instances, by default it's going to try to balance it across multiple availability zones. So auto scaling group in conjunction with load balancer enables you for high availability within a region. It's not high availability across regions. It's only within a region that you can get high availability and fault tolerance. So even if one availability zone itself goes down, you will still be able to redirect your traffic to a healthy instance in another availability zone just by using a load balancer. And you can scale accordingly within that same availability zone by using auto scaling group, right? So there is something called as auto scaling lifecycle hooks. So this is actually part of the professional exam. I don't know whether they actually asked this in the associate exam, but to give you an idea about what this is, so there are some lifecycle states that an instance goes through when it is part of an auto scaling group, right? So that instance goes from a pending state to in service state. But if suppose, let's say for example, before that instance goes to in service state, I would like to run a bash script where I am registering that instance to an monitoring service and so on. So if suppose I am having a monitoring application that would like that instance to be registered with that, what I can do is, instead of moving that instance directly to the in service state, I can allow it to transition from pending to pending wait. So in the pending wait stage, my instance will be running, but in the sense it will be running a bash script which will automatically register this instance with a monitoring service. And then what we can also do is, with a simple CFN signal, or let's say with a simple CLI signal, we can send that instance from pending wait to pending proceed. And the second we send that instance to pending proceed, it automatically goes to the in service state. Okay, so this is the use case when you want to scale out, when new instances are launched into your auto scaling group. But if suppose an instance is terminated by the auto scaling group, then what happens? It goes to the terminating stage. But then there also you have two lifecycle hooks, which is called as terminating wait and terminating proceed. So which use case would be ideal over here? Maybe if suppose you would like to take all of the logs from that instance using a logs agent that you had previously installed, and you would like all of the logs to go ahead and upload to a specific durable storage like S3 and so on. You can upload all of those logs when the instance is in terminating wait stage, where the instance will still be active and will still be performing some tasks. And once the logs have been sent to a durable storage like S3 and so on, you can send a CLI signal to transition it from terminating wait stage to terminating proceed stage. And then finally, when you move it to terminating proceed state, automatically it goes to the terminated state where the instance is scrapped by AWS. Okay, so these are the lifecycle hooks that are allowed for an auto scaling group. So you have pending wait and pending proceed on the pending side. You have terminating wait and terminating proceed on the terminating side. Okay, so the next thing that we will look at is regarding the notification, because if you are a system administrator, you would generally like to get some notifications, right? So if suppose an auto scaling group is launching a new instance into your group, or if suppose the auto scaling the auto scaling group is terminating an instance in your auto scaling group, or if suppose an instance fails to launch, or if suppose an instance fails to terminate. So based on these four events, which is instance launching, instance terminating, instance fails to launch, instance fails to terminate, you can get SNS notifications. So we have studied about SNS when we were working with SNS and S3 events. So similar to that over here, what we can do is we can specify a SNS topic. And for that SNS topic, we can go ahead and specify a subscriber to be the email address of that particular system administrator's email address or your organization's email address, where you can at least monitor what happens within an auto scaling group whenever an event occurs, like launching an instance or terminating an instance, or an instance fails to launch or instance fails to terminate. So other than that, even when you specify a scaling policy, so when you say that, right, when you say that when the CPU utilization is greater than 80% or the CPU utilization is greater than 70%, you would like to launch some instances, right? Even over there, you can specify an SNS topic and you can get notifications whenever an auto scaling group is scaling out or whenever an auto scaling group is scaling in. And again, you can get notifications whenever these four events occurs, where an instance launches, when an instance terminates, when an instance fails to launch, and an instance fails to terminate. So you get enough a notification when you work with auto scaling group. You get enough a vision into what's happening when you're working with an auto scaling group. So keeping all of these in mind, let's look at a particular architecture diagram that we'll be implementing today, and then let's go ahead and implement that diagram. Okay. So when you see over here, I already have an architecture diagram written for you guys. So in this architecture diagram, what we have over here is, so let me scroll this down. So you have an availability zone within a region. You have another availability zone within the same region. So if you consider this to be US East 1, you have US East 1A to be one of the availability zones. US East 1B to be one of the availability zones. So what we have done over here is we have mapped one subnet, or we could also call that as a public subnet, because we are working with the default VPC over here. We are not creating our own VPCs, so that is for a later lecture. So we are creating a public subnet with and mapping it to availability zone US East 1A. We are creating another public subnet mapping it to availability zone US East 1B. And then both of these availability zones are wrapped within an auto scaling group. So now the auto scaling group is going to monitor both of these availability zones, and it's going to launch instances across these availability zones. And then you have an application load balancer from which the auto scaling group is getting all of those health related details of our instances. And this application load balancer is doing nothing but monitoring our EC2 instances and distributing traffic to those EC2 instances residing within both the availability zones. So one small catch over here that people have to understand, generally the mistake that people do is, whatever availability zones you have mentioned for the load balancer, please do mention the same availability zones when it comes to the auto scaling group. Okay, because if suppose you mention 3 availability zones over here and you mention 4 availability zones for the auto scaling group, you will run into a problem where if suppose the auto scaling group spawns a new instance into an availability zone that is not being monitored by the load balancer, you may not get traffic going to that instance. So always remember, if you are mentioning 3 or 4 availability zones over here, mention the same set of availability zones for the auto scaling group. Okay, so it's a pretty simple architecture. What we are going to do first is we are going to create our load balancer, and then we are going to create our launch configuration for our EC2 instances, and then we are going to create our auto scaling group, which spans across the same AZs that we have mentioned for the load balancer. Okay, so let me escape from this diagram. Let me go back to EC2 where I have already logged in. So now let's go ahead and create the load balancer. We have already done this before, so it's going to be pretty simple and easy. So we are going to choose an application load balancer. So on the left side bottom corner, choose load balancers. Click on create load balancer. And we are going to choose the application load balancer. So once we have chosen the application load balancer, we are going to give it a name. So I'm just calling it as my ALB. I'm going to keep it as internet facing because it's a public facing load balancer. The listener is going to be HTTP because my instances are going to be with HTTP protocol. And then you can see over here, we are choosing our default VPC where we have 6 availability zones mapped to specific subnets. So what I'm going to do for best practices, I'm going to choose at least 3 availability zones over here. And then I'm going to choose the same 3 availability zones for HA purposes on the auto scaling group. So you have US East 1A, 1B, and 1C chosen over here. Let's click on the security settings. It's giving you a disclaimer stating that you have to use HTTPS. I'm not going to go with that right now. So I'm going to choose an security group for my load balancer. So I already have one, but instead I'm going to create a new one just for this lab purpose. So I've gone ahead and created a security group, and by default, I'm going to leave HTTP access to the outside world, right? So that anyone can query my request on the load balancer. Anyone can access my load balancer's DNS name. So next, what I'm going to do is go ahead and create a default target group. I'm not going to register any instances. I'm going to allow the auto scaling group to register my instances. So I'm just going to create the default target group. I'm going to call it as default ASG TG. I'm going to leave all of these settings as the default. We already spoke about these settings when we created the load balancer in the previous lab. So I'm just going to bring down the interval alone to 10 seconds. And I'm going to bring down the healthy threshold to 2 seconds. 2 healthy thresholds, 2 consecutive healthy thresholds, right? So I'll just explain these pretty quick. So healthy thresholds mean that you have to specify 2 healthy thresholds. So that means your instance has to pass 2 consecutive health checks in order for it to be deemed as healthy. If it fails 2 consecutive health checks, it will be deemed as unhealthy. How much time should I wait in order to get a response from my server? And between how many intervals should I do the health checks? And my response code can be 200 to 299, which can also be mentioned as a range of success codes. I'm just going to leave it as 200. And then the health check path is going to be / on my instances. The protocol is going to be HTTP. And even the target group is going to be working on protocol HTTP and port 80. And I'm going to choose the target type to be of instances because we are launching EC2 instances. Okay. And now I'm not going to register any targets because I mean, because we are going to allow the auto scaling group to launch the targets, and then we are going to allow it to automatically register it with the load balancer. So we are not going to register any targets manually. Okay, I'm just going to go ahead and click on review, click on create. So I have created a dummy load balancer which does not have any targets registered to it. The reason why we created the load balancer at the start is because it takes at least 3 to 4 minutes for the load balancer to come up. In the meantime, I will walk you through the configuration of creating launch configurations and auto scaling group. So one thing that we will have to remember is we have mentioned the availability zones on the load balancer to be US East 1A, 1B, and 1C. Okay, so now let's go down to auto scaling section where we have launch configuration and auto scaling group. Let's click on launch configuration. Let's go ahead and create a new launch configuration. You can see that it's pretty similar, the same steps that we followed when we went ahead and created an EC2 instance. So this is my favorite AMI that I'm going to choose. So I'm going to go with this AMI, which is the Amazon Linux, the older version of it. And then I'm going to stick within the free tier. So I'm going to go with T2 Micro. I'm going to click on configure details. And then you can see over here, we have to give the launch configuration a name. So I'm going to give the launch configuration a name. So I have given the launch configuration name called as my LC. And you can see over here, you can request for spot instances within your launch configuration, which means you will not get any on-demand instances. You will only get spot instances. And always remember that if you want to use a combination of on-demand and spot, you should go for launch template and not launch configuration. So I'm not going to choose any IAM roles, but under the advanced details, I'm going to input a bash script that is going to install a very lightweight web server called as HTTPD. And then it's going to serve my website on port 80. So this bash script is going to be run the second my instance goes from pending state to the running state. So I don't have to go into the instance, SSH into the instance, and then go ahead and install some software. So I'm just going to write down the bash script and let me go ahead and explain it once I have typed it down. So I'll just zoom and I'll show you. So let me just do a zoom. So you can see over here that we have called the bash interpreter, and then we have elevated our privileges to super user. We have updated the operating system using the yum update -y, and then we have installed the lightweight web server called as HTTPD, and then we have started the lightweight web server. We are keeping it running through restarts of this virtual machine, which the launch configuration is going to be part of. And then we are going within the HTML directory, and then we are just echoing out hello world to index.html file, which is going to reside within the HTML directory. So keeping these commands in mind, what we are going to do next is we are going to go ahead and choose our storage. So the storage is going to be 8 gigs of volume for the root storage, which is going to be of type general purpose SSD. We are going to leave these the defaults, and we are going to go to a security group that can be used by the launch configuration, which means used by the EC2 instances. So I'm going to create a new security group. So I've called it as my LCSG. I'm going to open up port HTTP over here. Other than port SSH, I'm just going to open up port HTTP, and I'm going to leave it to be accessed from anywhere. And I really don't want to open up port 22 on my virtual machine because I'm pretty sure that bash script will run. But if suppose you would like to do any kind of troubleshooting, it's good that you open up port 22 to your own IP address rather than opening it up to the entire world. So what do I mean by that is, please do open port 22 for any kind of troubleshooting and choose my IP rather than anywhere, because choosing anywhere is not a good practice. So choose my IP over there. Okay. So I'm just going to remove that. I'm going to go with only HTTP right now. I'm going to review, and in the review screen, you can see that we have the bash script that we inputted is now in user data place where it's base 64 encoded. So to test it out, all you can do is just copy this guy and put it into an online base 64 decoder and find out what's the value of this, which is nothing but our bash script that we inputted, all those Linux commands, right? So go ahead and create the launch configuration. I'm going to choose a key pair, which is my key pair, which I have created for my own purposes. So for people who don't know how to create a key pair, please do view the EC2 lecture to get to know about that. Go ahead and click on create launch configuration. So the second that you finish creating the launch configuration, it's automatically going to redirect you to create an auto scaling group using this launch configuration. So that's the button that we are going to click. So now we are in the auto scaling groups configuration. So we are going to give the group a name. So let's give it as web server ASG. This is your desired capacity. Always remember this. So I'm going to go with 2 instances as my desired capacity for splitting it across multiple availability zones. And then I'm going to choose my default VPC, and I'm going to choose US East 1B, 1A, and 1C. Sorry. So these are the 3 availability zones that we chose for the load balancer. We are going to choose the same 3 availability zones for the auto scaling group. Okay. And the next one that we are going to do is under advanced details, we are going to receive the traffic from 1 or more load balancers. And then we are going to choose our target group because we didn't use any classic load balancer. We used an application load balancer. So we are going to choose our default ASG TG target group that we created for our application load balancer. Okay. And then the health check type is going to be not of type EC2. It's going to be of type ELB because the auto scaling group is going to do the health checks only from the ELB. Okay. And the health check grace period is 300 seconds, which is the default. We are going to leave it the same. And for auto scaling group to launch instances on our behalf, it needs a service link role, which is created by default in IAM for us. We don't have to create the role by ourselves. So just remember guys, because it's going to create EC2 instances on your behalf, where you have given the auto scaling group the configuration, you have to also give the authorization to the auto scaling group to do it on your behalf. So wherever there is a statement where something is doing on your behalf, someone is doing something on your behalf, there should be an IAM role which is associated with it. So that's the reason why we have a service linked role over here for the auto scaling group where it can launch instances on our behalf. So you can view the role in IAM just by clicking on this. Okay. So next, since we have specified that our auto scaling group is going to start with a desired capacity of 2 EC2 instances, and it's going to be spread across 3 availability zones, and it's going to receive traffic from 1 or more load balancers. And the target group is the target group that we created when we created our application load balancer. And the health check type is going to be of type ELB. The next thing that we'll have to do is go ahead and configure our scaling policies. So with the scaling policies, I'm not going to keep it at its initial size. We are going to do something complex over here. So we are going to adjust the scaling capacity and also go with not this type of scaling. We are going to click on this blue string over here that is telling us using simple or step scaling policy. So where we are going to increase our group size based on a metric and decrease our group size based on a metric. Okay. So what we are going to do is I'm going to repeat it again, use scaling policies to adjust. And then there is going to be this particular, rather than target tracking, we are going to go with simple and step scaling, right? Where we are going to go with increasing the group size and decreasing the group size. And we are going to scale between 2 EC2 instances and 4 EC2 instances, where 2 will be my minimum capacity and 4 will be my maximum capacity. So right now we have 2 as our desired, 2 as our minimum, and 4 as our maximum. So for increasing the group size, you have to create a new CloudWatch alarm. So we are going to click on this, which is going to ask us to create a new CloudWatch alarm. And we are going to create a new topic over here. And the topic that we are going to call as, so this is an SNS topic that you'll have to specify, where you'll be getting a mail whenever a scaling action occurs. Okay. So I'm going to put my email ID over here and give the topic a name. So I'm going to give the topic a name called as my ASG increase group size notif, but let's keep it short. So increase group notif. Let's keep it short. There may be size constraints. So I'm just going to give the email address over here. So what this is going to do for us is it's going to create an SNS topic and then subscribe our email address to that SNS topic. So that means for sure you will get an email where you have to confirm to the subscription to receive any further email. So don't forget about that, guys. You will have to confirm to the subscription. Okay. So now what we are going to do over here is we are going to choose the CPU utilization, but you can see that we can choose any one of these metrics. We can go with disk reads, disk writes, network metrics, as well as CPU utilization, but we will keep it as CPU utilization for our purpose right now. And if it's greater than 80% for one consecutive period of 1 minute continuously, if it's going to be greater than 80% for one consecutive period of 1 minute, we are going to create an alarm, and then we are going to take the action to add 2 EC2 instances. if it's greater than 80%. Okay, and we are going to, since we have a bash script, right, any new instances that are going to be launched by the auto scaling group, we are going to give it at least 180 seconds to warm up, which means only after 180 seconds it's going to be registered with the load balancer and it's going to be doing health checks from the load balancer side. The reason why you are giving it 180 seconds is because at least 3 minutes, because we have written a bash script that is going to install our lightweight web server. So similarly, we are going to do the configuration for decreasing the group size. We are going to add a new alarm. So we're going to create a new topic. I'm going to give this topic a name. I have called it as my ASG decrease group notif. I'm going to put my same email address. And over here, where the average CPU utilization is less than equal to 20%. Average CPU utilization less than equal to 20% for 1 consecutive minute. I'm going to create an alarm where I'm going to remove 1 EC2 instance. If suppose it's less than 20% the CPU utilization, I'm going to remove 1 EC2 instance in order to just save cost. But these scaling policies will be based on your application's demand. So if it's a high critical application or a business critical application where it will at least need 5 or 6 EC2 instances to be running for base capacity, keep your desired itself as 5 or 6. And then the scaling can be done whether you have peak load and you want to save cost, it can be done using spot instances. But if you want to go with on demand also, you can go with on demand. Or what you can possibly do is have reserved instances, which we spoke about in the pricing model. Have reserved instances for your base capacity, and over reserved instance you can scale with spot instances in order to save much more costs. So it's, depends on how you want the architecture to be. So right now what we have is on demand, which we are launching, and even for peak scaling we are also going to launch only on demand. We are not going to launch spot instances, right? So we'll go to the next configuration where we are configuring the notifications. So like I mentioned, we can have notifications for whenever an instance launches, whenever an instance terminates, whenever an instance fails to launch, or whenever an instance fails to terminate. So we are going to create a new topic again for here. We are going to call it as my ASG notif, put our same email address. We are going to use the same email address. Okay, so we will get notification to our email address whenever these things happen within our auto scaling group. But then always remember guys that you'll have to confirm to the subscription in your mail. Okay, don't forget that. Okay, next all we are going to do is configure tags. So I'm just going to give a name tag and a value over here. I've given the value as my ASG, and it will also tag any new instances with this tag. So always remember, tags are very important when you want to go ahead and do any kind of cost control in your environment, and you want to find out which auto scaling group is probably part of which project. So in that way, I would always suggest you to give meaningful names for your tags. Okay, let's go ahead and click on review, and let's go ahead and click on create auto scaling group. So from the previous times that I've done this over the last few years, sometimes it may not work in the first attempt itself. Sometimes it may work in the first attempt. Whatever happens, it's totally fine. Okay, so let's create the auto scaling group. So it's creating the scaling policies, creating the notification. So it's perfect the first time. If some people don't get it right the first time, please do follow my lecture, or else there is going to be a button over here which is going to state retry failed tasks. So it may take 1 or 2 minutes to create the IAM role for the first time that you do the auto scaling lab, but the second time onwards it should create properly. So for the first time alone, you may get a retry failed task button over here. It's totally fine. Click on that. Automatically you will get your auto scaling group working fine. Okay, let's click on close, and now let's look at our auto scaling group and see some of the activities that's happening. So activity history over here, you can see that there are 2 instances which it's trying to launch automatically, because it has to maintain our desired capacity. Sorry, I didn't get that word. So it has to always maintain our desired capacity, which is 2. So it's trying to launch 2 EC2 instances. Let's just refresh and see whether it's successful or not. So it's successful. So it's launched 2 EC2 instances right now. And I'm just going to walk you through the settings of auto scaling group over here, right? And then let's look at some of these settings. So under the details, you can see over here, we have the availability zone that we have mentioned, the ELB that we have mentioned, and you can see we have mentioned our launch configuration. So if suppose you would like to update your auto scaling group with another launch configuration, all you have to do is click on edit and change the launch configuration to another launch configuration, and then go ahead and click on save. What's going to happen then is it's going to try to launch new EC2 instances with your updated launch configuration. So like I mentioned, at any point of time, you can only have one launch configuration associated with your auto scaling group. So the next thing on this tab is called as activity history. And the third tab is where we have our scaling policies. And the fourth tab is where we have our instances that have been launched. And you can see both the instances are in service status. So I'll give you one more information over here is it has spread it across two availability zones, which is US East 1C and 1B, which is really good for high availability purposes. So even if 1B fails, we will still be able to go ahead and present our traffic from US East 1C. So one more thing to note over here is if suppose you would like to update one of your instances and then you would not like to do that when your instance is in service status in the auto scaling group, what you can possibly do is you can put your instances in standby status, or you can detach the instance from the auto scaling group itself directly. And then you can manage it and maintain it as it's a standalone instance rather than part of an auto scaling group. So that is also possible. Okay. So under the monitoring tab, you get some monitoring metrics from CloudWatch. These are the default metrics that you get from CloudWatch for your auto scaling group. And this is on every 5-minute basis granularity, right? And then under notifications, we have configured our notification already. And under scheduled actions, what you can do is you can create a scheduled action wherein you can specify your min, max, and desired capacity. And you can specify whether you want the recurrence to happen only once, or you want it to happen every week, or you want it to happen every 1 hour, or you want to specify a cron syntax, right? And then you can also specify your start time, which is a particular month date of a particular year with the timestamp, which is at 12 o'clock midnight or 9:30 in the morning when you want to start your Black Friday sale and so on. So you can do schedule scaling policy also. And then finally, when we studied about the lifecycle hooks, we studied about the lifecycle hooks for whenever an instance launches or terminates, right? Regarding when the pending and pending wait status, and terminating wait and terminating proceed status. So pending wait, pending proceed, terminating wait, and terminating proceed whenever an instance launches and whenever an instance terminates, right? So other than all of these configurations, let us look at some of the configurations of our launch configuration. So once we created our launch configuration, you can see that we can create an auto scaling group with that launch configuration, or we can copy it to a launch template, or we can copy the launch configuration to another launch configuration and then modify some of the settings and then associate the updated launch configuration to our auto scaling group like I previously showed you. So that is also possible, right? So now let's just look at whether our instances are in healthy status, and let's look at our load balancer, whether they are registered as targets. So two EC2 instances have been launched called as my ASG. Let's look at our target groups and see if both of them have come to a healthy status. So let's look at the target groups. So on the left side, click on target groups. Under targets, you should see both the instances are in healthy status right now, which is perfect, right? It's perfect that it's working right now. So what we can do is go ahead and use the load balancer to go ahead and view our website, which we created through our bash script. So let's go to the DNS name and then let's paste it on the browser, and we should see hello world displayed. So we can see hello world displayed because we opened up port 80 on our load balancer, right? And we also opened up port 80 on our EC2 instances. So the load balancer can now go ahead and talk to our EC2 instances security group also through port HTTP and port 80 and protocol HTTP, right? So if you want to tighten the security groups, which we studied before, what you can possibly do is go to security groups, look for your security groups that you associated with the instances. So let me find out that security group by directly looking at the instances. So let us look at one of the security groups over here. So it was called as my LCSG. And you can see over here, we've opened up port 80 to the outside world. That's the reason why the load balancer was able to hit it. Otherwise, the load balancer won't be able to hit it. So let's do one more configuration over here to tie it down much more so that only the load balancer can talk rather than we directly talking to that instance over port 80. So let's edit this inbound rules. Instead of giving it as 00 over here, we are going to put a security group of the load balancer itself. So this is my security group of the load balancer, my ALB SG ASG. This is a security group of my load balancer. I'm going to remove this 00. I'm going to go ahead and click on save rules. So now what this is going to do is only my load balancer can directly talk to my instances. I can't talk to my instances directly. So let's look at the load balancer security group just to be sure if we did the configuration right. So the load balancer security group will be mentioned below over here. Yes, we have put the correct security group only. So now what we can also do is, since we are working with auto scaling groups, let's see if it tries to maintain the desired capacity. Let's manually go ahead and terminate one EC2 instance. So that is where the fun starts. So let's go ahead and remove this EC2 instance and let's keep our fingers crossed and let's wait and see what the auto scaling group does. So we have terminated this EC2 instance. It's gone to the shutting down state, which means it will automatically be deregistered from the target group. You can see there is only one healthy instance right now, and that is in the US East 1B. So the 1C instance was the one that we removed. Now let's look at the auto scaling group, and let's look at the activity history over here, and let's see if it tries to maintain that desired capacity. So it's going to check every 300 seconds, which is our health check grace period. It's going to check every 300 seconds and see if our the number of healthy hosts is maintaining our desired capacity. So let's wait for some time right now. It's going to be an awkward pass, but stick with me, guys. It's going to be an awkward pass, but let's wait for 300 seconds to see what happens and how the auto scaling group reacts to it. So let's just wait for some time and see. So I've showed you most of the other configurations regarding this. So let's just wait and see right now. So I'm going to put myself on mute. So let's just wait. Okay, so as you guys can see over here, since we terminated that EC2 instance, it's now deregistering that from the auto scaling group. And now you can see over here, once we refresh once more, it's waiting for the ELB connection draining. And in the meantime, it's going to go ahead and launch one more EC2 instance for us. So let's just wait for some more time. So under instances, you should see that that instance should have gone to the terminating state, terminated stage. So, and you can see one more EC2 instance has been launched. It's in the pending state. Let's go down to the auto scaling group and let's look at this once more. So under activity history, you can see that it has already launched one more EC2 instance over here, which is still not yet in service. And you can see that once that has come to the running status and it's gone to in service status. In the meantime, this the instance that we terminated will automatically be deregistered from the load balancer. So let's go to the target groups and let's see. So in our target groups under targets, you can see over here that one EC2 instance is in the initial status. So since we gave the EC2 instance 180 seconds to warm up before it goes ahead and registers itself with the load balancer, you can see that it's in the initial status right now. So after some time, it will also come to the healthy status. Beautiful. So it has come to the healthy status. And in the meantime, we can go ahead and look at the auto scaling group and see that whether it has deregistered that instance from the load balancer. So it's still waiting for the ELB connection draining on this particular instance that we terminated, but after some time even this status should be completed, and we should see that the two desired capacity is always maintained by the auto scaling group. So this is all I wanted to mention for the auto scaling group, guys. So one thing to remember always is don't try to delete your EC2 instances first and then go ahead and terminate your infrastructure. So to terminate your infrastructure, I would always suggest you guys to go ahead and delete the auto scaling group first. So let's go ahead and delete the auto scaling group first. And then let's go ahead and delete our launch configuration second. And then let's go ahead and delete our EC2 instances. Because if you don't delete the auto scaling group first, what happens is in the meantime, it starts spawning any new instances. So let's go ahead and delete the EC2 instances. And now let's go ahead and terminate our load balancer that we created. So let's go ahead and delete the load balancer. So let's click on delete, click on delete. And now let's remove our target group also that we created. So delete the target group. Yes. Okay. So cool. So this is regarding the lab regarding auto scaling group and launch configuration. Hope you had fun. So I'm gonna stop the recording right now. Open up for any questions.